following data in this first table gives the number of potholes on 35 randomly selected 1-mile stretches of city highway. And our instructions are to complete the frequency, which is the second table, and the relative frequency, which is the third table below. And then there's another question beyond that. But let's start off with the frequency table. And these are simply counts. So you want to first find out how many ones there are in this first table, and I might suggest just marking them off. And as you mark them off, you'll count them. So there's a 1, another one is 2, another one is 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 ones. Do the same for the 2's. There's 1, 2, 3, 4, 5, 6 2's. 3's, 1, 2, 3, 4, 5. So there are 5 3's. 4's, 1, 2, 3, 4. So there are 4 4's. 5's, 1, 2, 3. That's it. So there are 3 5's. 6's, 1, 2, 3. So there are 3 6's. And finally the 7's, 1, 2, 3, 4. Now notice when you mark them off like this, you can look back and make sure you didn't miss one. And then you total and make sure you really do get 35. That's another good check. So you've got 10 plus 6 is 16, plus 5 is 21, plus 4 is 25, plus 3 is 28, plus 3 is 31, plus 4 is 35. And if you look over here, you've got 7 rows and 5 columns, so that's also 35. It always makes you feel good to cross-check everything. So that's the frequency table. That was one of the things they asked us to do. Now the relative frequency is simply the for each number of potholes is the frequency divided by the total. So for the potholes, for the ones with 1 pothole, that would be 10 over 35. So it'd be 10 over 35. Now I'm leaving some room because they're asking us to write these as decimals, written with 4 decimal places. You just have to pay attention. Sometimes they let you leave the answer as fractions. Sometimes they tell you to do something different. You just have to do whatever you're asked to do. And if you actually take the calculator and do that, you'll find out that that comes out to be 0.2857. And then for 2 potholes, that's 6 over 35. So there's the 10 over 35. Now there's 6 over 35. And if you take your calculator and do that calculation, you'll end up with 0.1714. And then 5 over 35 for the 3's. And that comes out to be 0.1429. And then 4 over 35. Which comes out to be 0.1143. And then 3 over 35. And actually the next 2 are 3's, so I can go ahead and do them both at once. And 3 over 35 comes out to be 0.0857. And finally 7 is 4 over 35, and I've done that one already as well, so I can just copy that down from above. That's 0.1143. Now, if you want to be sure that you haven't made some careless mistake, if you add up those fractions, or the decimals or the fractions, either way, you should get 1. And with the decimals, it should be at least within rounding error of 1. Since you're rounding something off to 4, it's possible that you would miss 1, but it should be within rounding error of 1. That makes you feel better that you haven't made some careless mistake. So we've got the frequency table now, and we've got the relative frequency table. The last question simply says which represents the bar graph for this data set. And I guess we should look at that. You could actually just draw the bar graph, but if you're given a multiple choice problem where, hang on just a second. Okay, now you can actually see the graphs. You could actually just do the whole bar graph and then compare it, but since you're given the possibilities, your choices, you might as well take advantage of that and just look at the places where they're different and figure it out from there. For example, if I look at all of the bar graph heights for 1, I'll notice that they're not all the same. So if I look back, and these are actual numbers, they're not percentages. On the vertical axis, these are numbers. So they're referring back to the frequency table, not the relative frequency table. If there were percentages on the vertical axis, then you'd be looking at the relative frequency table. So all you've got to do is look. Now, for 1, we know that there are 10. The frequency is 10. So B does not have a frequency of 10, so it's out of contention. And C has 8, it's not 10 either. A and D both have the right number of for the frequency for one pothole. Now you might look and see where A and D differ, and I noticed right away that they differ for 7, because A goes above the 4 mark, I guess easy to see on A, but for the D choice, it's right at 4. So really all you need to do now is look and see that for 7 potholes, the frequency is 4, and that tells you immediately that between A and D, it would have to be D. So we didn't actually draw the whole bar graph. We could have, and maybe we should have, but if you're just going for the answer, you can do this by elimination without drawing the whole thing. The following bar graph compares women's and men's hourly wages in a recent year. And on the vertical axis, they're telling you the age group, and horizontally, they're listing the percentages. The red or orangish color is for men, and the yellow color is for women. And they're asking us about women, so we really don't care anything about the red bars at all. We're strictly looking at the yellow bars. And they're also asking us about the age group from 20 to 24, so we really don't care anything about that at all, or that at all. So obviously we're strictly looking at this 20 to 24 bar that represents the women, which is the yellow. So that's the only thing in that whole graph that we're concerned about. And they want us to say how many or what percentage of women aged 20 to 24 earn 750 per hour or less, and that's what this chart tells us. So we just read the percentage off of the graph. Now that's 11. It goes about halfway beyond that, so I would say there's about 11.5% of the women aged 20 to 24 that earn 750 or less per hour. Strictly reading the graph. The following are the number of home runs hit by the home run champions of the National League for the years 75 to 89 and for the years 93 to 2007. And the first row represents the first category, 75 to 89. The second row represents the second interval, 93 to 2007. And beside each of those is a listing of the number of home runs hit by the home run champs in the National League for those years. And we want to compare those home run records by completing the back-to-back stem and leaf plots below. Now, once you know how to do these, they're extremely easy. The stem is listed in the middle. So the stems 3, 4, 5, 6, and 7, and that simply represents the first digit. So if we're looking at this 3 stem, we're looking at those numbers, 38, 38, 37, 36, 37, 37, 39. And we simply write the leaves, which are the second digits, and we put them in numerical order going outward from the stem. So the smallest of the 30s seems to be, ooh, I missed one. There's one right there, a 31. So the 1 would go here, and I'll just sort of mark it off there. The next smallest one seems to be a 6. So I'll write it down and mark that off. And then there are quite a few 7s. 1, 2, 3. So 1, 2, 3 7s. And there are 2 8s, it looks like. So we have 8, 8. And I believe there's 1 9, and I would think that's it. Let's count and see. That's 1, 2, 3, 4, 5, 6, 7, 8. And go up here and count 1, 2, 3, 4, 5, 6, 7, 8. That looks good. Now let's do the 4s. And I'm just sticking with the 75 to 89 right now. If we're looking at the 4s, I've got a 4, 0, and I've got a 4, 8, and a 4, 8, and a 4, 0, and a 4, 9, and a 4, 7. So listing those in order, it looks as if I've got 2 40s, so I've got to write down 0 twice for the 4 stem. Then it skips way up. I go all the way, I think, to 47, and I think there's just one of those. There are a couple of 8s, 48 here, 48 here. And I believe we're down to just 1 9. Then you move to the stem of 5s. There's a 5. In fact, that's the only one, 52, so it would be there. And I believe I've done them all. There are no 6s and 7s. So that's the first category taken care of. Now let's move to the 93 to 2007, do the same thing. If we start off looking at 3s, you'll find out there aren't any. But there are quite a few 4s. So here's a 4, 6, a 4, 3, a 4, 0, a 4, 7, a 4, 9, a 4, 9, a 4, 7, a 4, 8, and that looks it. So if you start off and doing them in order, there's a 4, 0, and I believe there's only one of those. So I'll mark it off and write the 0 after the 4. And there is no 1. I don't see a 2. There is a 4, 3. And I believe that's the only one. There's no 4. There's no 5. But there is a 4, 6. But there's only one of them. Now there's a couple of 4, 7s. There's a 4, 7, and there's a 4, 7. So 7, 7. There's a 4, 8, but there's only one of those. But there are a couple of 9s. There's a 4, 9, and a 4, 9, and I believe that does the 4 stems. So now move to 5s. Well, there's a 5-0 and a 5-1 and a 5-8 and another 5-0. So I just said there seems to be two 5-0s. So let's get rid of those up here. There is a 5-1, but then there's only one left, and that skips all the way to 5-8. Now notice marking these things off above is helpful, because if you miss one, you can tell that you missed it. And now we move to the sixes. There's a 6 there, and actually that seems to be the only one. So put the 6-5 in and mark it off. And the rest of them are 7s. There's 1, 2, and there's a 7-0 and a 7-3. And notice I've marked all of those off. So there is my back-to-back stem and leaf display. And looking at that, there's a question I want to ask about it, and let's bring that question. And the question is, during which period, the earlier period or the later period, did the home run champions hit significantly more home runs? And all you really have to do is glance, and you can see just by looking that the earlier years really don't have anything in the higher areas, whereas the latter period is weighted much more heavy toward the bigger numbers. So the answer, of course, would be, just by observation, that the 1993 to 2007 period definitely there's a significant number of home runs in favor of that period.